Welcome back, welcome back. So whether or not you joined me in the last video for the very first question on the very first Friar, the 2003 Friar, or whether or not you're just jumping right in and watching this video where we're going to be covering the second question, the 2003 Friar, question number 2. Welcome, welcome. So not a whole lot to say. How about we just take a look at what question number 2 is? It's a game involving Xavier and Yolanda. So, in a game, Xavier and Yolanda take turns calling out whole numbers. The first number called must be a whole number between and including 1 and 9. Okay, so Xavier could call out 6, and then Yolanda could call out another whole number. Each number called after the first must be a whole number, which is 1 to 10 greater than the previous number called. So Xavier could call out 6 on the first turn, and then Yolanda could call 7, or she could call 8, or she could call 16, or any of the numbers in between there. And then Xavier, so we could have 6 is called, and then maybe 10 is called, then maybe 20 is called, then maybe 21, then maybe 30, something like that. That's the sequence of play. That's how the game works. Calling out whole numbers and taking turns. The first time the game is played, the person who calls the number 15 is the winner. So since the numbers have to be greater, somebody's going to have to approach 15 from below, and you want to call 15. So no one's going to be calling out 16 or anything like that. Explain why Xavier has a winning strategy if he goes first and calls 4. Okay. So, this is sort of one of those questions where you have to analyze a game to a certain degree. So, Xavier goes first, he calls 4, he should have a winning strategy, we just need to explain that strategy. So, if he goes first and calls 4, what could Yolanda do? Because if he has a winning strategy, then really no matter what Yolanda does, he should be able to win. So how about we take just a look at it, we're just going to explore the question a little bit. Now these are kind of long names, and they're chosen for a reason. It's Xavier and Yolanda, XY. So, maybe we can make a little chart or something. So on turn 1, Xavier calls 4. Now, what on earth could Yolanda call? It's turn number 2. Yolanda, what could she do? Well, let's just blindly think, not thinking any strategy for Yolanda, what could she call? She could call 5. Okay? So then, that's the end of her turn. Now it's Xavier's turn, and he can call a number 1 to 10 greater, so he would call 15 and win. Our turn, person, call. 1, 2, we could have X calls 4. Remember, this is the strategy. We just need to explain this. Y could call 6. Then Xavier would call 15, and he'd be done. Okay, so it looks like on the third turn, Xavier can just jump straight to 15. Is there any way Yolanda can stop this? Well, by playing low, the lowest she can play is 5. Xavier still wins, so maybe she can play too high. Maybe she can get 15 herself. Turn 1, 2, 3, maybe we'll have to do a 4 or something. X, Y, and then it'll be X's turn. So he calls 4, that's a given. What if Y calls the highest she can possibly do? So on the second round, the third round, the fourth round, the number needs to be 1 to 10 greater. What if she calls 14? That's not 15. She still can't claim it. Xavier gets 15. So why does this work? No matter what Yolanda calls, she can't get 15. Okay, that's why she can't claim victory. But Xavier always seems to be able to make up the difference. No matter what Y calls, X can always seem to call 15. Okay, we haven't rigorously checked this. We're getting a sense of things. Okay, but 4 is more than 10 less. That's a weird statement. More than 10 less than 15. So Y can't call 15 from 4. But so the big thing here is 4 to 15 is 11. 11 is just out of reach of the range of numbers we can call. We can call anything from 1 to 10 greater. 11 is too great to call, but no matter what Yolanda calls, if she calls 1, 10 can be called. If she calls 2, then we can go up by 9. If she goes up by 3, we can go up by 8. If she goes up by 4, then Xavier goes up by 7. So we can always make up a difference of 11 in 2 turns. We can always force 11. So that's the idea. No matter what Y adds to our total, X can always make up the difference of 11 and go from 4 to 15 on his next turn, or go up to 15 on his next turn. So we can explain this a little better. So the next number, the number that Y calls, is going to be n plus Y for some whole number Y. Then we notice that the number 11 minus Y that's also between 1 and 10. Okay? We had a theory, we had an idea. Right? The idea was, 4 gets called, then Y does something, but no matter what, X gets 15. Y can't just jump to 15 because there's more of a difference than 10. There's a difference of exactly 11. So the idea is, no matter what Y calls, X can make it so that the difference between the number he just called and the number he's calling now is 11. What we're trying to do now is explain that, prove that, just justify that in some way. So according to the rules of the game, X can call out n plus Y plus 11 minus Y. So regardless of what y calls, x can get, or not call out. Notice that this wouldn't work for n plus 12. He can't guarantee that he can call n plus 12. Because, let's say n is 3. So x calls out 3. Y would call out 4. And so x can't get 15. He can't get 3 plus 12. He can't guarantee that, but he can always guarantee getting n plus 11. Okay, he has to go back and make sure that to get 15, to know that he'll get 15, he has to make sure that he can get 15 minus 11, which is 4. So on his next turn, he can win. So we have explained why 4 was important. We've explained how he wins. Right? If whatever y calls, he just makes up the difference of 11. And we've explained how from 15 we need 4. So we've justified his solution. We explained why he can win. Or why he will win. Assuming he's not a moron. Alright. So that's his winning strategy. If whatever y calls, he just makes up the difference of 11. So B part. The second time the game is played, the person who calls the number 50 is the winner. If X goes first, how does he guarantee that he will win? Okay. Well, we've already done a lot of the legwork. We know that if he wants to call 50, he has to make sure that he calls 50 minus 11, which is 39. So how about we start writing some of this down? Oh, sorry, 50 minus 11 equals 39. Getting ahead of myself. Okay. So, in order to get 50, he wants to call out 39. So, we don't have a strategy yet, because we don't know how he gets to 39, but we have an idea. Right? We can reduce the problem of Xavier trying to win. He wants to call out 50. We can reduce it not to a problem of how does he get to 50, but now it's a problem of how does he get to 39. So he wants to call 39. That will definitely get him 50. How does he definitely call 39? So if he wants 39, he's going to have to call out 39 minus 11. That way, no matter what y does, no matter what y calls out, x will be able to call out 39 on his next move. Well, if he must call 28, then he needs to call 28 minus 11, which is 17. So he's going to have to call out 6. But we were told x goes first. So that's his winning strategy. We've explained it. Since he goes first, and 6 is between 1 and 9, remember that's the condition for the first number, he can call out number 6. Then no matter what y does, he just makes up the difference, calls 11 more than 6, or 17 on his next go. So the game could go something like, he calls out 6, then Yolanda calls out 8. Then he can still call out 17. Then maybe Yolanda calls out 24. Then X calls 28. Then 32 is called. And then 39. And then maybe 49. And then finally 50 for Xavier. So for it to be a winning strategy, he has to be able to plan for everything that y does. Okay, if y were to call a number, if he calls 6 and y were to call 7, he needs to know what to do next. Okay, he then calls 17 because he can. Then after that, he'll call 28, then 39, then finally 50. So for questions like this, when you want to analyze a game, you need to figure out the rules, and since it's the math contest, you need to figure out mathematically what the rules mean, how they interact, things like that. But for winning strategies, or to show that there isn't a winning strategy, you need to be able to say, okay, if X has a winning strategy, on X's turn, this happens. This is what X does. That's the only thing X can control. And then you have to say, okay, well then Y could do this, 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 or this. How does X respond in each situation? And then you need to show that over time X will get the win. That's in general how you do any of these game-style questions. They crop up occasionally in contests, especially written ones, because, well, we had to describe the winning strategy there. Okay, so let's go back and take a look at the whole question. Right, B, the second time the game is played, the person who calls the number 50 is the winner. If Xavier goes first, how does he guarantee that he will win? All right, So we explained in part A why the number 11 was significant, and then in part B we used it. We said he wants to get 50, he's got to get 39, then he's got to get 28, then he's got 17, then he's got 6. We worked backwards from the winning conditions, which is often something that's a good strategy. So from the winning conditions, we realized he's got to call 6. And then no matter what y does, x calls 17. Then no matter what y does, x can then call 28, and so on and so forth. And that concludes B part of question number 2. It was a nice little game theory style question. So that was very nice. And yeah, so join me next time as we explore question number 3. The Friar only has 4 questions, but the first year they did these extensions. So I'm just going to do the main contest, and maybe I'll do the extensions in another video, or several videos if the extensions are particularly long. But yeah, so if you wondered why I'm not doing the extensions, that's why. But you should certainly try them, and maybe I'll do them in another video. But for now, that concludes question number 2, so I will see you guys for question number 3 in the next video. Thanks for watching.